Zoran Popović is professor of computer science and director of the Center for Game Science at the University of Washington, as well as the founder of a fascinating company called EnLearn. Welcome, Zoran.
Thanks.
It's all yours.
Let me just give you a brief background. I come from a country that no longer exists. It's been broken down into 6 separate countries. I came to this country as an exchange student in high school. Spent the entire year trying to get a scholarship because that was the only way I could sort of learn about computers at the time. One thing led to another. I ended up being a faculty of computer science at the University of Washington. But along the way, it was clear to me that so many things had to align perfectly, and I was lucky in so many different ways along the way. And that always stuck with me. It was obvious that so many people would be nowhere near as lucky as me for things to align so well. And about 15 years ago, instead of just thinking about that, I decided to sort of devote everything that I do in my research towards the goal of not making luck be the function of anything. Everybody should really be able to reach their full potential. I started doing a lot of things in mathematics, published a lot of papers. A lot of them were deployed in the video game industry. But the interesting thing that happened, at some point somebody said, well, we have this problem in biochemistry. We're trying to predict how proteins look. And we try to have computers do it by themselves. It's not working out so well. So we spent a lot of time asking, how can we actually have people who know nothing about biochemistry be able to contribute to this thing? And after many, many failures and eventually some success, this is what happened. If we look at sort of the best people that were trained through this sort of scientific discovery game experience, you see that 3/4 of them had one undergraduate course of chemistry or less. So really, they knew nothing about proteins, proteomics, and biochemistry. But those people were able to not publish one paper, but now actually in preparation, 6th paper in Nature, which is the most eminent scientific journal. So just to give you a sense of what some of these discoveries were, one of the proteins was posed to us by scientists who worked on it for 13 years. They couldn't figure out exactly how the protein looks. So say, well, let's just see what protein folded trained experts can do. In 10 days, this structure was discovered. So we had 13 years, 10 days. Obviously, that hit the press big time. But the key thing for me really was this previous slide, which is that somehow we found an alternate pathway for people to just not go through the standard process of going through college, graduate school, postdoc, in order to actually do science, but to actually do world-class science by completely new pathways. And I've explored that since in neuroscience, and more recently, this was just in New York Times, we sped up the neuroscience process by almost 4 times compared to what neuroscientists were doing. And neuroscience labs around the world are now realizing that people that have learned this in this completely alternate way are so good at it that they want to actually, they're writing grants to hire more people who were trained through the process of these scientific discovery games. I've been thinking about this for a while, but the key thing was, well, why can't we just do this for all education? We can't just be doing it just for one little niche here, one little niche there. The key realization that led a lot of my research and things that I've done subsequently is that the way we do education at large, it doesn't, K-12, workforce readiness, college, whatever you pick, is that we think of it in this monolithic way. So first, we're anchored to a very rigid curriculum instruction. So there's no rhyme or reason that a curriculum is just a one linear sequence of things that's a textbook or maybe a sequence of things online that you should be doing. Really, the curriculum depends on a person and what is the most appropriate thing for that person to learn because they want to upskill to a specific job that they want to take. Second, we oftentimes ignore the unique needs of a learner. What I mean by that is we sort of have this one number of like mastery or proficiency of something. But in reality, there are many other things that make us who we are, and how we learn is affected a lot more by that number than how much do I believe in myself in terms of what I can do? What is my strategy when I'm stuck? All of those things are both sort of aspects of a person. What are the things that really inspire me? What are the things that make me not want to quit? All of those things really need to be accounted for. And then finally, we ignore the entire learning environment. We sort of say, well, the textbook is a textbook. It'll be applied to anywhere, no matter where the subject is taught. And it turns out that, depending on what kind of teacher support, peer support, classroom size things, all of these things make a huge impact. So just to give you a little bit of insight of how restricted we are in what we have now, if we look at one kind of curriculum right now, we can kind of break it down into a set of components. Let's just say each one of those little circles is a component of curriculum. If we look at another curriculum, well, it has some overlap, but it kind of has the similar amount of stuff. But through my research, when I look at that curriculum and how much extra stuff we need to cover to address the need of every individual learner, it turns out the space is this large. Okay? So oftentimes, this is 20 to 100 times fewer than what we really need to personalize for every unique person. So not only is it small, but it also has a very narrow coverage. So we can cover some little things that some writer of a curriculum has done, but in reality, there are many more things that might be appropriate for different learner such that they can learn in the most efficient way. So the question is, how do we move away from these siloed, fixed curricula into these highly variable ones that can really get us to much greater outcomes? Here's another example of how kind of sad really the situation is. If we look at the ordering of concepts that we should be presenting such that it's ideal for somebody to learn, let's say, algebra, it turns out, and if we look at 0 as sort of random ordering, so we're just going to give you a random section and see how well you learn with that. And if we look at sort of the expert-based section, it turns out that for this particular domain, it was doing worse than random. Okay? This is not because the experts are really bad experts. They're really brilliant people. It's just that the space is so complicated, it's really hard to just pick one linear thing that's just going to be right just in general, and especially for a specific person. And if we look at sort of the most powerful adaptive one, these are all sort of different variations of adaptive algorithms, you see that there's a significant improvement that you can make compared to the status quo. So those are the things that we're not doing in education in general, but there's been this long promise, and I'm as guilty as everybody else in this edtech space, is that you think that you kind of feel like, well, technology should really be able to help in a profound way, not in just an incremental way. But it kind of, I have to admit, it hasn't, right? So the question is, and I've spent a lot of time thinking about this, why are we not moving the needle in some specific, significant way? And my conclusion is that we're misdirecting the technology to all the wrong places. So let me just give you some examples. We have these intelligent tutors. We've had them since 1960s. They have fairly sophisticated algorithms. They've been shown to work really well as long as the student is chained to the chair and cannot leave. But the key thing is that they're trying to replicate the teacher, right? So forget about the instructor. You don't need an instructor. Let's just do computer, person. Let's go do it. And that premise by itself is flawed. First, because technology cannot even come close to doing many things that an instructor can do. And so instead of just trying to replace it, the key question for technology is, how can we amplify the instructors to be as powerful as they possibly can? So here's another example. So we've taken these video lectures and we made them available to everybody. Of course, that's great, right? But the problem is that in terms of all the things that can be done in an instructional space, the actual passive lecturing, where you just listen and absorb information, is kind of the least effective thing you could be doing in a classroom. So there we are, taking the technology and taking that piece out into hoping that they will make a difference. Well, it will make some difference, but very small. Third, we're, again, looking at the mastery based on some really hard numbers instead of looking at non-cognitive and metacognitive aspects of a person. And what I mean by non-cognitive aspects is, what is my engagement into this? What is my ability to struggle? What are my problem-solving skills that I can apply to any situation? If you don't develop those skills at the same time as a curriculum, it's very, very, very hard to make a difference. In fact, every time I conduct an experiment and say which things matter most for students learning, these factors turn out to be way stronger than anything I could be doing for the particular algebra curriculum. Okay? Yet, technology, by and large, ignores it. Second, of course, we have these great algorithms. We all publish great innovations, but really, they don't have enough tools to act them. And I'll give you a little bit of example of what I mean by that. Remember this curriculum, this orange curriculum? If you have an adaptive algorithm, and these are the components that it can work with, what the adaptive algorithm can do is say, oh, okay, I'll give the students this, and then this, or then maybe I'll go back to here, and those are my choices. So it doesn't matter what sophisticated, highfalutin algorithm you have. If those are your choices to what to present to the student, the limits of what you can do, it doesn't matter what algorithms you have. So this is another way in which we've misdirected our focus. Turns out the technology can actually do a very powerful thing in making this scalpel precision instead of blunt tools that we're using today. So imagine having the entire full space where every student would have their own personal path with problems custom tailored and generally exactly based on what they need, not just from the perspective of learning, but from the perspective of persevering and feeling empowered by solving these problems. Okay, so what if we could address all those items? And I have spent a lot of time trying to say, how can the technology address these things? Let's have an example. So actually, I'm going to skip this one. What if our goal really is, for the entire technology, is to create real equity? Okay? I don't know anybody who takes technology and focuses on that specific space. And really, that's what we should be doing. If we look at sort of progressions through grades, if you look at these dotted lines here, that's the average at which students improve for every grade. Now, we have a lot of students that are sort of, forever destined to be below that particular average. And somehow it's assumed as long as they have the same velocity, maybe we're doing OK. But in reality, what we really want, if we really want to address equity, you need to basically allow every person to reach their full potential, no matter where they are. They don't need to be below average. They may have potential to be as good as they possibly can be. But the question for technology is, what, for a specific given time, because we don't have extra time, we don't have infinite time, we have a fixed amount of time, how can we, for that fixed amount of time, have everybody be able to reach their particular potential? And the only way to do that is if the velocity of this curve is drastically stronger than anything that current curricula can provide. So that's the key objective that the technology should be doing. If we look at sort of adult learning, workforce readiness, college, et cetera, and maybe some people were long removed from college. So what happens is when you're removed from college is that dotted line doesn't go up anymore. It actually goes down because over time you've forgotten a lot of things that you've learned in the past. So therein lies our challenge. Somebody could be at arbitrary, their knowledge at that point is kind of like Swiss cheese. There are many missing pieces. The key question for technology is, how can I, in the most efficient time, without going to the remediation purgatory for a year or 2 years, but to actually sort of together, if I'm a nurse, I need to learn statistics, but I don't have enough algebra. How can I get just the right amount of algebra for every every day of statistics such that I'm just ready to absorb that new piece of material. That's the kind of curriculum that we really should be striving for. And here's the list of set of things that I've identified as the key things that we need. And I have not found any technological solution that actually addresses either one of them. So first one is focus on the whole person, right? So figure out how can you get that inspired learning, productive struggle, how can you change the mindset? Second is how can you adjust the entire support structure? Namely, it's not just how can a computer adjust to the student, but there's the entire environment. There are peers that can help to learning. There's a classroom, there are instructors, there are TAs. So the question is, how can we take all of those resources and use the technology to be aware of them and to maximize the actual outcomes of the students based on knowing that curriculum? And not only that, but how can we, given that the environment somewhere else is different, dynamically adjust for that specific unique need? Third, and this was, to me, I realized after observing many ways in which people get discouraged and walk away from trying to do things, is you cannot waste a second. By the time people are willing to take another course to upskill, to reskill to something, it's probably like 10, 11 at night after they put kids to sleep. They already went to work. They're exhausted, right? So how much time do you have? How much time of actually really do you have? It's very limited. So the key thing is that you should not waste a single second of that time. So that means in real time adjust exactly on what the student needs, such that within every 5 minutes they see that they have moved from not understanding something to having understood something. If you don't have that fine-grained feedback loop that happens frequently, it's very easy to have people be discouraged. Another point is don't teach what you don't need. Okay? So our structures of education is always like, oh, you need this course, or maybe you need this other course. So more recently, we're doing sort of this, we're breaking those things up in co-requisite module models, but they're still sort of pretty large modules. I mean, it takes you a while to go through that module. What if you could, not know something, and 20 minutes later, you can absorb and know everything that you need? And the final one is, how can you learn by doing? Okay, so this is how we learn. We're built to learn by doing. We're not built to learn by observing, abstractly internalizing, analyzing, and then mapping onto something that we need to do. That's very, very hard to do. Very, very few people can do that. So the question is, how can we learn everything by just starting to do it, and then everything that we need that we're missing, we get it just in time based on what we need, right? That's the principle that ends up sort of being very efficient and gives people sort of the direct purpose of what they're trying to do. So I've tried to address all of those items. The key things in technology that I have worked on to enable this is I realized that if I don't want to waste a second and I want to create a curriculum that's just what the student needs, I need to be able to follow the learner thinking process throughout the entire time. So I need to build technology that can sort of understand what the person is thinking, which misconceptions they had, such that I can create the curriculum to, as fast as possible, remove those misconceptions. Then, of course, if I wanted to have on-the-fly curriculum, I need to have a completely different representation of what knowledge means. So we worked a lot on that. And then finally, we created these adaptive algorithms. They're not standard machine learning algorithms because, and believe me, I tried those first. They don't work. The reason why they don't work is that education is a high-stakes environment. If you can tell me, oh, I have this great algorithm, and after first 10,000 students having spent 2 years on it, it's going to be really good. Everybody's going to look at you and say, well, forget about it. That just doesn't work. I need an algorithm that will help the very first student, and the very next student will immediately improve their learning from what it has learned from the previous student. So in the high-stakes environments, you need completely different algorithms. Then don't waste the second of what we've learned from any other students. So if we can do all those things, what is possible? Let me give you some examples. What if we wanted to teach the general population of the entire country how to solve these three equations for x, okay? And how to have full fluency in doing this. And what if we said, so this is 7th, 8th grade material, obviously a big requirement for college readiness in a lot of places. But what if we can do this for anybody, including elementary school kids? So when I posed that question, everybody was like, Zoran, you're totally off the wall. But we tried this. We didn't try it just one place. We tried it in many different places. We tried it in a whole country of Norway, later on in Uruguay. We conducted it many times in Washington State, because that's where we're from. We did it in Minnesota as well. And here are the outcomes. The biggest outcome was that any teacher in any classroom that participated for at least an hour and a half. So there's no cherry picking. Anybody in that entire country that participated, that entire classroom reached mastery, defined by solving those questions. 96% of all of those classrooms reached mastery. Okay, so that kind of thing is possible. Let me give you another example. This is an adult learner about to start community college. Really had serious doubts of what they can what they can do about math. Just the look of math was sort of intimidating. We gave them a pretest. We give them on paper because we really want to see if the technology can transfer their knowledge onto other medium rather than just do it in the platform. And so they did this test. They scored 0 on it. Okay? So we had them on our platform for 19 minutes. After 19 minutes on the platform, they were able to solve an equivalent test without any mistakes. Okay, now these are still pilot tests. These are isolated instances. We've had other people do it within 19 to 30 minutes. But these are the kind of goals that we're going for. And there is no free lunch. There's no way you can get to there without doing all these things that I mentioned. But if there's one thing that you can draw from this presentation today, it's that these things are actually possible. Let me just give you one other aspect of this thing, which is, as I was mentioning, if we can optimize for both non-cognitive and metacognitive goals. Some of you have heard a lot about sort of different badging and ranking. I've done a lot of studies on this. It works as a spike, but it just goes flat down. Nobody's incentivized by these things after a long period of time. So it doesn't really work in the long run. But what we're trying to do is do something different. We say, what if engagement could be student agency, productive struggle, metacognitive skills, a mindset change, or persistence? What if we can reward those? And so the good news is the mindset can be taught. This is work, we worked with Carol Dweck on this. We had a 20,000 student trial where we presented 2 different things. We incentivize them in a standard way, which is the more problems you solve, the better you are. That's the sad truth of how we do education. But the other condition we said is, doesn't matter how many problems you solve. If you productively struggle, you're going to get more what we call brain points. And after just 30 minutes of encouraging these things, so for example, new idea, fresh start, working hard, measurements, these are the kind of outcomes after just 30 minutes. The struggling students, those that I was particularly focusing on, are staying and trying to solve a really hard problem that we knew nobody would be able to solve. It's that hard. But that particular population ends up persisting on that problem significantly more than even advanced students. So imagine if 30 minutes can do that, what can the entire curriculum do if we incentivize those particular set of structures? Here's another shocking example from this study. People who didn't care about how many problems they solved 35% more problems than people who were rewarded by how many problems they solved. So we have the whole incentive structure completely wrong, and there's so much more stuff we can do. So with the remaining 7 seconds, I want to leave you with a set of things that I hope we can take away from these 48 hours into the future. First, if you're looking at technology to solve problems, look at the technology or any other solution that can actually scale. If the solution cannot scale, we cannot address equity. Second, don't expect that a small tweak, technological or otherwise, will make a big difference. It's just not going to happen. You need to actually have changes that really make a difference, and oftentimes they're not cheap in order for that to happen. The third point is the complex systems, like education, do not get better by us thinking harder about it. We need to have very tight iteration loops. So the teacher, the student, everybody needs to know within a minute or second exactly where they are, how they're doing, and how much they're improving. Unless you have those feedback loops that frequently, you will forever be destined to improving at glacial speeds. So we really need to think about, first and foremost, what are the iteration loops that we can do here? And finally, don't give up on technology. Demand that it specializes for your specific needs. Because if somebody tells you there's a technology and it just works for everybody equally, I can just tell you that's not going to happen. So ask, how is this technology going to specialize uniquely to my needs, to my students? And then finally, hopefully you've gotten something from this talk, is that much larger things are possible in education. So instead of saying, oh, OK, this helped me with 2%, ask, how can I have every one of my students reach full mastery without spending exorbitant amounts of time on this? Because I really believe that that's possible. Thank you.